As quiz goes, you will see something like your 1, your 2. I said I didn't put indirect or direct variation on the quiz. Obviously, we'll come back on looking more like a 1, a 2, where you're going to get, just like we just did, a data sample. You're going to have to figure out if it is linear, quadratic, or cubic. You're going to have to write the regression based on your calculator, and then it's going to give you some sort of a thing. Like C gave you find the average rate of change for number 1, and then C for number 2 asks you to predict. Okay, so there's going to be questions based on those regressions. Questions on either of those? Yeah. So when you map it, okay, I'm pretty sure it doesn't go down then up again, right? So a down would be like a literal down. It would be a lower point that brings it then up.
Technically, this is lower.
Why do you have that there even? Oh, that's your regression? Yeah, so it should come up. Like it doesn't go down at all. It would have to be significant. It would have to have some point down. Oh, I hate notability. Oh, because you're on your Apple Pencil. You would have to have it here. All right, this was the first one. When you graph the data, stop it. Okay, it gets really cut off. Depending on what your data is going to be, you're going to have to be able to adjust this window. Same thing is going to happen for your quiz and your test. So if I look at my X values, the lowest is 14, the highest is 53. So I need to at least have that in my window. So I could go literally like 10 to 53 or 55 if I want to go a little bit past it. And then the Y minimum, the minimum on that Y was what, 48, and the highest is 138. So I could go 45 and I could go 140. You have to make sure you grasp that whole curve, okay? That curve takes a mostly quadratic shape. Remember, it's not going to be perfect. If it's going to be cubic, you're going to see more of an up and then back down again. So I would say if it was cubic, you're going to see it have points up here or down here where it goes up, comes back down again, and then goes back up again. So I would say just be really, really careful. This one is, and somebody even said like, well, this looks linear. Sure, it does, but you need these points to be included too, which means it looks more quadratic, okay? If you did, so like, Carmen, based on what you were looking at, if you did it as as cubic, and you saw your line go like this and it doesn't match up at all, hopefully that's a good indication. When I graph this as quadratic, so if I go to my stat plot and I do quadratic and then I store it, it almost completely overlaps with it. Okay, so again, it's not going to be perfect, but it should really have a good indication of where it's going.
Can you do number C?
Mm-hmm.
C
part of this. Yep. So once you, okay, try to do it with 2 hands. When you're trying to find the average rate of F, so if you've stored it in Y1, then I'm going to do F. I want to do my fraction. I'll show you what it looks like when I actually type it in. And then Y1 of 40 minus Y1 of 20 over 40 minus 20. God bless you.
See, I got 1.6522.
Oh, it's going to be because of the, is that on here? So they probably used this instead of keeping it exact. So there will be a range on there, I would say, for answers. Okay. If you physically, because there's calculators that aren't storing it, so like a Raoul situation, it's not storing it, then I'm going to give you, if you plug it in here. And then also if you keep it exact, which is the better answer, which would be, God bless you, 1.652. Yeah. So there'll be a range in there for answers. Don't stress out if you got 1.652, you did it more accurately because you stored your Y1. not all calculators are allowing the store of y1. So in that situation, you'd have to take that 0.73x squared and plug in 40, plug in 20, and then do it as 40 over 20. So that's probably, I would assume, where that's that 1.626 comes from. All right, questions on 2. This was linear, okay? Your linear graph is negative 3.487x plus 92.873. Did the same thing happen with this one?
Yeah.
The rounding's a little bit off, probably because, let's see, 75.
368.
So negative 3.487 times 5 plus 92.873. Yeah, so this comes from actually using that instead of keeping it exact.
Okay.
So I'd give you both.
Okay.
Yeah.
Can you do number 3?
So 3 says the value of y is inversely proportional to the product of 4 and x squared. If y is 12 when x is 2, then find the value of y when x equals 6. So I'll be honest, the wording on this, I couldn't figure out if they meant 4 times x squared or 4x squared. But if you do either way, you get the same answer. So as long as you're consistent in your equation, it didn't matter. So if I got y equals something that is inversely proportional is going to be underneath the k. Product of 4 and x squared could have been 4 and x squared, or it could have been the product of 4 and x squared, which is, I think, is what it should be. But they did both give the same answer. Then if 12 is y, and we don't know k, and x is 2, and then we're going to square it, we'd get 12 equals k over 8 squared. 12 equals k over 64. And then k ended up being 12 times 64. 768. And then you would do y equals 768 over 4x squared. And it says x is 6. So 768 over 4 times 6 squared. So 24 squared goes there. And it's 768 over 576, which is 1.33 repeated.
Where did you get the 768 from?
So it depended on how you set up the first time. If you did 4 times x squared and the 4x was inside the parentheses, k was 768. If you did 4 times x, I think this way. Oh, that's the same way. If you did 4 times x squared and 4 not inside the parentheses, then you would have gotten 12 equals k over 4 times 4, k equals 12 times 16.
Does it matter
Oops.
if you put before?
It actually didn't. You got the same answer. 192 was what you would have put in the top, and then it would have been y equals 192 over 4x squared. And then your x was 6. Y equals 192 over 4 times 36. And 4 times 36 is 144. And 192 over 144 is still 1.33.
But generally speaking, it doesn't matter.
I mean, usually, I would say it's only because it is a product squared that it didn't matter. If you're adding something or you're doing something separate like that, it's going to matter, obviously. And that would be like the sum of this and this squared, and the second thing would be squared. Yep. Otherwise, it would say the square of the sum. That's the difference. So if it said the square of the sum, then whatever you're putting in here gets squared. If it is the sum of something and the square of, I don't know, whatever x, then that does not get parentheses, just the x gets squared. So you got to be really careful on the wording there. I don't know that it's going to throw you that far off, but okay. When you plot your data, so like here's my data, right? Oh, let me make sure it's cleared out. When I graph my data, no matter what your initial window is, if you want to adjust it, if you go window, nope, just kidding. If you go zoom, 9 says zoom stat. It will literally zoom based on your numbers. So you don't have to figure out your window. I know, I was watching a video today trying to learn how to do this on the other calculator, and this popped up, and I was like, seriously? Why wasn't this on the tutorial in the beginning? Did you see what that was? Yes? Okay. So plot your data. Go to graph and hit zoom and go to number 9. Zoom stat. It will literally fix your window. So now if I go back to my window, you'll see my window is fixed to show the data that I have. Okay. 4 says the time it takes to mow a lawn is inversely proportional to the number of workers. So time is inversely means divided by the workers. And the divided by numerator is your K. So you do your constant over what you're dividing by. So time equals the constant over the workers. And then it will give you the first pairing. It takes 3 workers, so that's my workers. 45 minutes, 45 is my time, to mow a lawn. So then I do 45 equals K over 3 and multiply both sides by 3, and I get 135 for my K. Then I have to plug in K now with the one piece of information they give you the second time. How long will it take for 4 workers? So they're giving me the W to mow the lawn. So I don't know time this time, but I know my K is 135, and I know it's 4 workers. And then when you divide that, you get 33.75 minutes. Yeah.
How would you know that it's like the it's 4x?
You know, I actually did it both ways, and you got the same answer. Because I couldn't differentiate. So the wording on this one is really, because if it's a sum, if you say the sum of this and something squared, now you're talking about the sum of it squared. If you say the square of the sum, now it's the sum inside in parentheses squared. So that, to me, made more sense. But this, I couldn't figure it out. I did it both ways, and they both gave the same answer. So it said y is inversely proportional to the product of 4 and x squared. And I didn't know if that meant the product of 4 and x squared, like that, or the product of 4 and x squared. So I tried it both ways, and they both gave me the same answer. How did I get the same answer, or how? Say again?
How'd you get the same answer for the
The K is different, but the ratio is still the same. So here, look. I did y is inversely proportional to the product of 4 and x squared. So let's do it this way first. If y is 12 when x is 2, then I'd get 12 equals k over 16, and k equals 12 times 16, which was, what, 192. And then y equals 192 over 4x squared is my model. When you want to find the value of y when x is 6, y would equal 192 over 4 times 36. That's this one over here. 192 over 144, which is 1.33. Then the other way to look at it is y is inversely proportional to the product of 4 and x squared. Y is still 12. 4 times 2 squared is 12 equals k over 8 squared, or 64. And k equals 64, I see you, you're good, times 12, which is 768. And then y equals 768 over 4x squared. And this time, again, the x is 6. So I do y equals, wait, why did I put it? Yeah, no, it's fine. 768 over 24 squared. 24 squared is, I already did this work. I don't want to have to look it up again. Oh, I didn't. Oh, yeah. Thank you. No, that's 12 squared, right? That's 576. And then 768 divided by 576 is the 1.33. So it doesn't matter which way you set it up initially, but it does matter that you use that same way both. Does that make sense?
So it doesn't matter on the test?
It didn't matter. Well, it would matter depending on the wording. In this case, where you're doing a sum and a test the week after next. Or the same for your piecewise function. So you're And then the piecewise functions, any questions on those? So A was 2, B was 8, and then A was 624, and B was 480.
Can I see your work for 4?
All right, the AP Classroom questions for 114. So the first one, it gave you the model 3.6 over d squared, and then it asked for the average rate of change from 2.3 to 3.1. So you could have individually plugged them in, or you could have plugged this in as your y equals 3.6 over d squared or x squared, and then found your average rate of change. It should have been negative 0.382. The second part of this said the table gives the expectancy, blah, 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 blah. It says it's a linear function where t is year 0, or the first one, sorry. So 1,000 or 2,000 would have been year 0. And then it wanted you to predict the life expectancy of 83 years. So you had to come up with a linear function. It told you it was linear, but it had to come up with a linear function where that was 0, and this was 4, and this was 8, and this was 12, and this was 16, and this was 19. You can't use the actual years. And then you would have gone to your regression, which was linear, and you would have gotten y, it would have been y equals 0.117x plus 76.988. And then instead of it saying, because our x is our birth year, it didn't say what would it be at the year 2083. Then I would have plugged in that as the x. It said what would be the life expectancy in that year if you were, what would it be in 83 years? Yeah. But let's go.
When it gives you years, you always find you don't use the actual years
Correct.
for every single time.
When it gives you a time, I mean, not even that, just like a time frame. Like if it said it started and then it was an hour and 30 minutes longer, like you're doing it based on it will usually say this is minute 1. So like t equals 0 is your first minute. And then whatever time after that that's accumulated, you're using that time instead of the actual physical time.
Can you go back to number 1?
Right? 3, 4. I did this last week, so let me remember. It says the law states the pressure gas inversely related to the volume of the gas is a constant temperature, so that's where this came from. The table gives the volume V in milliliters of gas for selected pressures. Which of the following model for the volume of gas as a function pressure? I just picked the first one. So this was your pressure, and this was your volume. So if it said that the pressure, right, it says the pressure is inversely proportional to the volume. So P was the pressure equals K over the volume. I put 137.5 in as the pressure. You don't know K. And I put 12 in as the volume. And then I solved for K, which ended up being 1650. You're welcome. That's when all those words are really important, and the order that they deliver them, because then you know how to set it up. Yeah.
So on tomorrow's quiz, there'll just be
The models.
And the functions, the inverse, or no?
The inverse is not there.
Oh.
No.
So it's just the stuff with the graph.
Yep.
And the piecewise aren't.
Correct. Not tomorrow. Yep. Proportional. 5 goes back to a linear. 5 could also be something that you could see. 6 is also a function. So 6 not on the quiz, but on your test. Yeah.
Do you have to always change the window every time you grab something on the computer?
I mean, unless you get lucky and it falls within your 10 to 10, but usually you've got to change it.
Okay, and if we change it, we make it like the Y min, we make it a little bit less? Or
Yeah, so that you can see the full thing.
Okay.
Especially if it's at 0, I go a little bit lower so you can see the
X to
axis.
go above, and then for the
Just
Y.
a little bit below, a little bit above, a little bit left, a little bit right.
Okay.
Yeah. When she comes back, yep. Carm. I'm going there next. And it says T1 corresponds to 2011. So it's telling you make that 1. So 2011 is your 1. T2 corresponds to 2012. That's your 2. So, it literally says it in the problem.
Okay, so then,
It will usually, it says T equals.
and then it always continues
if the increments are the same, like this increment was the same, but remember the one that we did yesterday with Jeff Bezos, it skipped increments, so you have to go off of basic, like the increment should be a year, but if it jumps that, then your T doesn't go 1, 2, 3, it also has to jump to match. Which one's 3? The one inversely related? Oh no, 6 was your piece. All right, looking at number 1 here, it says the open top box is constructed by cutting squares that are x by x inches from the corners of an 11 by 2 inch and 13.3 inch rectangular piece of cardboard, then folding the sides of the box up to make the walls. The volume of the box is modeled by, and it gives you the big model, which of the following statements is true about the function? Since we're talking about a measurement, we would start by saying that there's a restriction on my x value, which is how long it is, being greater than 0. So all of these are greater than 0. Then I want to know what's the biggest value it can be. If you actually graph this function, it looks like this. It's a cubic function, so it looks like this. And if you look, notice that my domain is actually never gonna stop, but this first section goes from 0 to this point here, which is 5.6. And if you think about what you're talking about, a box that is 13.3 and 11.2, and we need to cut corners out of all the sides. Now those corners could be small, but they could also go up to half of this, which means, and it has to be square, so the biggest it could be is half that 11.2, which is the 5.6, which is consistent with that x-intercept. So 5.6 is the biggest an x can be to keep this square. Then, if you're looking for the range, you're going again from 0 to the highest point up here, which is 133.929. And that matches D. For 2, it says in 2016, the cost to mail a package is $2.54, which is how much this is. For up to 3 ounces, plus an additional cost of 20 cents for each additional ounce or portion. So as you move past there, it's 20 cents more. So this is going to go to $2.74 and $2.94 and so on, climbing by 20 cents each time. Which of the following describes the restrictions on the range for such a function? The range is all positive real numbers would not be true because the range is not all real numbers, specifically which would be y is greater than or equal to 0. The range is positive integers. Now we're talking about all integers being whole numbers, 1, 2, 3, 4, and 5, go on and so on and so forth, which is also not true. These two are very similar. It's in the form of $2.54 plus 0.2x, which is the linear function, and that's correct. The difference here is that it says 1 is non-negative real numbers and 1 is non-negative integers. Real numbers means it's going to increase consistently like it's decimals, it's fractions, it's all the things in between. So that would produce a line or a linear function, whereas this is a piecewise function, and non-negative integers means it's going up in increments, which is what it's true. These are increasing by just integers, not in fractions themselves. So it's increasing in gaps each time, which is why D is the correct answer. The best model for an area would be quadratic. 4 got really confusing, okay? It said the table of values gives an average rate. Let me actually copy and paste this. Okay, it's a table of values, gives the average rates of change for the function. Which of the function is best modeled by a piecewise linear function with 2 linear segments of different slopes? So this is where it gets a little bit weird because when you're talking about piecewise functions, typically we say it's just one value. But you're talking about the best modeled piecewise linear function. So if I actually plotted these ranges from 0 to 1, the first one is 2.1. It would be something like this. Then it goes to 2. Then it goes to 2.1. Then it goes to 2.2. Then it goes to 2.1. Then it goes to 2.2. And then it goes to 2.0. So it almost says something like that for the first thing. If I look at The second one, it goes 2.1, 3.2, 4.2, 5.1, 6.3, 7.2, 8.3. The third one goes 2.1 or 2.0, 2.1, 4.2, 4.1, 4.2, 4.0. And the last one goes 3.2, 4.2, 5.1. Wait, did I skip one? This is F, this is G, this is H. This one goes, what did I end on? 5.1, 4.2, 3.2, 2.1. So of all these models, you're looking for a piecewise that really just has two linear segments with different slopes. This one stays pretty constant the whole time. This one has one increase here. This one has this little increase, and then this one, and this one has one that goes up and down like a quadratic. So visually, that's the one that's closest to having two linear with different slopes, because you're going up and you're coming down, okay? Whereas this is all the way up. This one just kind of stays constant the whole time. This one goes up and down like a quadratic. So that's why C is the best answer. Okay, 5, again, I thought it was pretty easy. That is roughly linear. So this one obviously takes that shape. And 6, you had to figure out the difference between the 6 had a cubic function because the third difference was non-zero. All right, your homework this evening is the extra practice for the quiz tomorrow, which is 114, okay? Get comfortable with that calculator. Obviously, you have to make sure you have it with you tomorrow. Make sure that it is charged because that whole thing is calculator-based. You can't do it without, okay? You don't have to turn it in and post the answers, but you do need to do that review.